let's try and find out motional EMF in rotating bar. Now assume that this is a bar, metallic bar, which is rotating in a magnetic field. Now we have put cross over here. Now since we have put it cross over here, the magnetic field is perpendicularly into the plane of paper. All right. Now this is the pivot and it's rotating in the magnetic field. Since the bar is cutting magnetic field, so we know that bar would generate EMF, which would be equal to BVL, where B is the magnetic field, L is the length, and V is the velocity with which it's rotating. Alright, obviously, since it's rotating, we have got to later on convert the linear velocity into angular velocity, where V is equal to R omega, which we would be applying later on. Okay. Now, we have already developed formula E is equal to EMF is equal to BVL. Now here, it is induced EMF in rotating rod. Now here, since it is induced EMF in rotating rod, so L would get converted into R. Alright, R. Now let's initially talk about small dE generated in the rod, which would be dE is equal to BV dR. Now on integrating this from 0 to L, it would be total EMF, which would be B integration 0 to L V dR. Now V we know is linear velocity. Since it's rotating, we have got to convert it into angular velocity. So the relationship is V is equal to R omega. So instead of V, we can write it as R omega integration of R omega dr. dr is the small radius. Alright. So B and omega being constant comes out of integration. So it becomes 0 to L integration R dr. And we have already seen how do we integrate. So the solution for this is half P omega L square. This is the motional EMF in rotating bar. So this is yet another formula which you have got to keep in mind whenever asked for EMF in a rotating bar in magnetic field B. Alright.